Hello everybody, welcome to another stream. How are we doing? So, last stream we added, we improved our tile binning. Well, I'll say improved, we still need to see if it's an improvement. We're trying to improve our tile binning by having a prepare spheres pass as well as which goes after the prepare clusters pass. So after we've selected our clusters to render, we go over all of those clusters to render, and then we simply check all the spheres in there, put them into screen space, see if they can be rendered, and then if they can be rendered, we add them to a few arrays. Really, we add them to this sort of spheres to render buffer, and we begin to add them to the tiled bin array, but we just put them in there with a sort key and sort indices. Where the sort key in the high bits has the tile index, and in the low bits it has the depth of the sphere. Then we go over and sort all of the spheres, and so now they become sorted by tile first and then by depth, so that we sorted from front to back. Which means we can do some lovely things like early out in the ray tracer, and also do alpha blending front to back, and anti-aliasing. So it should be pretty cool. Then our next problem is we need to know the ranges of these tiles, because we've just sorted the array. We don't know where each tile starts and where each tile ends. So we made these two shaders to account for that. And it basically finds where they start by looking for a pair. Looking for a pair of sort keys, and if the tile index differs, then it must mean we've found an edge where a start or end, an end and a start of a tile boundary. So we basically set all the start indices up. So we've got a bit of a problem with this though, and we're going to fix that. Fix this. So right now we have the ray tracer hooked up. So it simply only renders blue if the tile has spheres. So if we go ahead and give it a run, here we go. So it's shown up blue where the tile has spheres, but it's kind of wrong because the spheres are actually should be here underneath it. Yeah. So this is what we've got to fix. I got some ideas. One thing that I do want to quickly, I had a thought off stream. There was that we made this buffer prefix sum thing, and we didn't end up using it. And this was another way we was going to do it, but we encountered another problem. I'm thinking, let me just quickly, because it had a limitation of being limited to 1024 elements without multiple passes, multiple dispatches of this. But I think we could just, I think what we can do is quickly finish it off. Right, it's got entries count. Sweet. I just thought we could just put it in a for loop. It's probably going to call it base index. And then you probably want to call it like entry index offset or something like that, and base index is less than the number of entries in the array, and then we do base plus equal 1024 threads. So you can actually have all threads in the thread group go around this for loop and do the prefix sum, and they can all wait here for them all to finish and then go around again, which would be quite interesting. So I think this would be possible. Entry index equal base index plus entry index offset. Now you won't overflow, but I wonder if you have any inactive, you have inactive lanes, which is bad. So I think this needs to be rounded up to the nearest whatever. But yeah, anyway, I just wanted to jot that in there. This, because I do think it could be useful in the future. To finish this off before using it. Check everything makes sense. There is a bug with the for loop, as it expects all lanes or threads in a wave to be active. Yeah, so I think that's the solution I was missing, is we could just basically do a for loop. Oh, then you want to accumulate the value as well. Value, source value. So you'd have some kind of like accumulated value. Oh yeah, and add the accumulated value over the for loop. Over each for loop iteration. Right. Yeah. Right, so I just wanted to jot that down because I thought of that, how we could design it, and actually it could probably be pretty good. So that'd be done in a single pass, and it should be good because it just does 1024 threads at a time. But maybe there's a better version. Right, let's get back to what was actually working on, something that actually makes sense, or that's actually plugged in. So we've got this sort of like, we've got to find the starts of these tile bins. So we do it by checking for a pair of the sort keys, because it's a sorted array, and where the tile index differs, then this means that we have found a start and an end of a tile, of the tile entries. So we then had a bug where some of these would be invalid, and I tried to fix it by having this sort of valid range type of thing. Turns out it's a terrible idea. So what we need to do is just make sure it's just always valid. Yeah, these things, every tile has these things set, start indices set properly. So that's what we're going to focus on achieving, basically. Right. So, how can we do that? So, if a tile doesn't get this, if a tile doesn't have its entry start index set, we need it to get its proper value somehow. So we could memset it to some invalid value, but then it needs to be patched later on. But I don't know how will we do that in a good way? So the problem is you could spawn another pass after this. Check if your one is U32 max, right, an invalid value. And if your tile has an invalid value, you can look at your neighbor. But then what happens if your neighbor is invalid? And then that just becomes recursive. So I guess you could just for loop up and up and up, or down and down and down, until you find something. But then you also get tons of race conditions probably where the value is half written, so you need to use atomics, and that just slows the whole thing down. There's that. Or you could be like, you can instead be like, hey, I'm the one with a valid value. I'm going to look before me. And I'm the only one who can write before me, or something like that. And it's everyone's job to reach back, I think. Yeah, maybe that's the way to do it, I think. Yeah. So I think what we need to do is we need to insert a memset on GPU. So GPU memset, damn it, buffer memset, run out loud way. Where are these things? Just a little bit more wordy. Right, so I want to memset this thing here. No, sorry. Yeah, start indices, this one. Boom. So we memset the whole buffer to U32 max, that's the invalid value. These guys go ahead and try and set every one in here. And if it can't because there's no pair, then we need another shader. So the shader goes fill in gaps. And the job of this one is to say, hey, we get one thread per tile. And so you get your tile index. And the whole job of this is to say, I need to know how many tiles there are. How do I do that? In the globals. This one, sphere raytracer tiles count. And plop that in there. So if our tile index goes out of bounds, then we shall return. And the whole job of this one is to fish out the... So something only can write to a tile index, or in this array at a certain tile index if it is an invalid value and comes before a valid value. I guess you'd have a problem at the end of the array still, though, because you can have stuff at the end of the array. Maybe there could be a special case for that. Or if it's at the end of the array and it's U32 max, then maybe we can just min the value and it should be okay. Yeah, I think that's sensible. So we don't have to worry about the end of the array. We'll just min it. Min it with the yeah. That's fine. So we get our here. We're going to fish out the start index, and if that is equal to or not equal to u32 max, then this entry is completely fine, we do nothing. But if it's, wait a minute. No, if it's equal to u32 max, we are going to let another a valid thread. Hey there, Arbit, random user, how's it going? Long time no see, how you been? We're going to let a valid value from a thread with a valid value give us its value, thus creating an empty array for this tile. So we are something with a valid value now down here. So what we're going to do is we're just going to loop backwards, right, until we find the nearest one. So we say while that take away 1. So we'll loop backwards, we check the value, actually there can be a problem, we might have to use atomics, damn it. No, don't do this to me. See, you could do 32 threads in one go. You could do it on per thread group basis. Could be negligible though. I guess that might be an issue with it. Might need atomics then. Because if you take it out, yeah, and another thread is set. Oh, damn it. There is problems with that. Because another thread could just overwrite it and give you a proper value. Ain't good. Dot files. Yeah, I use both, I think. I don't know, I tried that TJ's Kickstart thing, and then I kind of broke it somehow, so I've just not bothered fixing it because I don't really need a lot of this stuff, but I was trying it out. Standard Vim was probably just fine. Yeah. Because my project's kind of small, and there's only so many files. But yeah. They're definitely nice to have, though. And essential for bigger projects. So, yeah, I guess this is problematic. So maybe you can only set your value, but then I guess you have a similar problem. If you can only set your value and someone goes and reads your value, say if everyone looks to the right hand side, so if every tile index scans up the array, maybe it doesn't write it until. Oh, we could do that thing we just designed. Just do 1024 at a time. What could we do? 1024 threads at a time. Everyone can pick up. I guess everyone can pick up a. start index and just do a wave active min. Maybe someone even a prefix min. Do I even have prefix min? I don't even have prefix min, that's not good. I have prefix sum though. Active prefix count bits, prefix product. Prefix min and max they're missing. I'm not sure if I'm going to need those for this though. It could be though. So the algorithm could be I'm going to pick up the start index and I need to find the closest. If my one is invalid, I need to find the closest one to the right. That is valid, and I can take that one. So I guess if you did like some form of thread group, you can do some control barriers and just get them to wait. And maybe that will be the way, perhaps. So if you end up doing some for loop with some base index of 0, and then going all the way up to something like this, you can then read tile index equals base index plus tile index offset and then read that out. And I guess you could say if I'm the one that's invalid, you put like a control barrier here. You probably want to sync with everything that's in a buffer, perhaps. And maybe you read it into LDS memory, but that's an optimization. You're not going to read 1024 values into LDS. You could do. Maybe there's enough. Because if you just pull them all into LDS memory, yeah, I don't know. That's like 4 KB of memory. I mean, you can search over that instead, and it'll probably be better. But equally, there's better optimizations you could make where you probably use all the waves and ask the waves if they've got. You make a bit set basically with the waves in LDS memory and say which ones have a value, and you store those in some smaller array or something. Yeah, I think this can definitely be heavily optimized. So should I do it now? So I think what we could do, right, is you can have. The thing is, though, if you're at the end of a. I was thinking you can say you can have a bit set for every one which has a the value, and then have a smaller array where those values go. And you can just fish them out of that smaller array. But if they're not in there, I guess you could do the search to the right. Yeah, it's definitely an optimization. Let's not bother about it for now. So the idea is basically just, so if I am not invalid, we are going to basically, okay, if I'm invalid, let's search to the right, get our value. By simply doing probably another for loop, search index equal 0, search index is less than, from tile index plus 1 all the way to the end of the array. Now I'm just going to search for the next active one because we just need it to work right now. And we can see how bad it is later. Right, search index. So if this value is valid, found tile index. So if we found a tile index that is not equal to E32 max, we're then going to take, this will then be our new value. Yeah, we can set entry index to be that. Found tile index. Wait, it's not tile index. What I'm talking about. Found entry start index. There we go. And then we'll break out that. And then, yeah, there's many optimizations you can do here. But so we want to put a control barrier down where we only want to be able to write back into the array when nothing else is reading it. So you put a control barrier down, and just for probably a none, is that even the thing nowadays? Atomics. Yeah. Let's just do all. Again, optimization. So you do one control barrier, all threads in the thread group wait there. There's nothing else writing or reading or writing from this point. So we can put, we write back a value. Now I don't think we will always want to write back a value because that will be, that might create more, that just might slow things down more. So what we should really do is say new entries index or whatever. We set that to like E32 max. I think, no, we set it to what it was. And then we say, okay, if this differs, then write the new one out. So we just need to update to the new one in the right places, which is here. Cool. Yeah, so I think that is the fix. Basically, we've got this fill in gaps thing now, which is quite nice. And it should fill in the gaps for those start indices now. So let's give it a go. We just need to dispatch it. Fill in gaps. We are launching, it's not indirect. It's just regular. It's just a direct dispatch. And and we've got to launch a divide roundup of the number of tiles, spheres, ray tracer tiles. This one. Oh, it's right below me. And 1024. I think that's going to work. Right, so don't bother reading from the sort keys. We just read right to the other buffer. We didn't do anything to the globals, just read. Okay, so now in the shader code, what we've got to fix is the this whole valid thing now, right? So in the tiled ray tracer, I did some silly stuff. No, wait a minute. So we get a tile index that we're in. And now we need to find all of the spheres that are in that tile. So hang on a minute. So this valid thing goes away now. Dumb idea. The start index is this. Now I'm thinking what we need to do. Spheres, ray tracer. Damn it. That one. Sphere, ray tracer. Tiles count. So if our index is in bounds, grab it. If not, it's the end of the array. Right, so I think we want to min. And also, what is this base sphere index thing? It's kind of silly. Silly naming. This should be called tile bind entries start index. And then probably the end index as well. Tile bind entries end index. Okay. So the next thing as well is we wanted to display. Yeah. Let's delete this. So this is now going to show blue on the screen if a tile has spheres in it. So we should only see that. I was getting glitches last time, which wasn't good. Right, okay. So hopefully this works. Give that a run. Okay. So that's interesting. We're not getting it. It's not always getting filled. The bottom left one is always showing something. This kind of changes a lot, which is still wrong. But at least it's still staying inside here. It seems like the lower left one should be bottom left. But the 0 tile is not being set to anything, I think. We'll look into that. So let's go back to this shader and understand why it's not filling in all of the gaps. Right, so oh shoot, it only needs to launch this once, doesn't it? It only needs to launch one group. Because it's going to for loop over the whole array anyway. That's the whole point. Okay. So for this over the whole array, and then there definitely needs to be a guard here. If tile index is less than. So I guess the others don't care about being inactive. I guess we'll just indent it. I'm not usually a fan of doing it this way, but screw it. Yeah, so if the tile index is inbounds, then do this. That was a problem. So read get your entries index. If that is an invalid index, we're going to search up the array until we find something that is valid. So if you're the bottom left one, which is 0, the 0, 1, you should have found something. Um, um, Alright, let's give that a go again. Okay, so still getting this weird pattern, which is just a bit random, really. Let's disable the occluders thing. Does this change the result? Hmm. Let's take a look at the code where we actually use this. I didn't min it with the end actually, did I? Some of these could be U32 max, I think. The issue. So what I really need to do is min this result with the end of the array. Tile bind entries max value, I guess we'll call it. So you want to wrap that. So in a minute with that, just in case this is U32 max, right? This could be the issue. And then this needs to be also wrapped in sort of max value thing as well. Alright, let's try that. See if we get anything different. No, nothing different still. Still got that one in the lower left here, which is glowing, and these are glowing as well, saying that there is spheres at these tiles, but there isn't the neighbors for some reason. So what we're going to use is the mouse position. So we're going to say if the mouse is at this coordinate. So we've got this passed in via the globals. So we can do that. So we're going to say if global mouse position dot x is less than or equal to, oh no, sorry. If ucore.x is less than or equal to the mouse position and the mouse position wait a minute, that's the pixel. Whoops. So we need to find out where the tile starts. Right, I got an idea. Tile coordinate multiplied by the tile dim. Right? If that, so that's the start of the tile in screen space basically. And then if that is less than this plus 1, gotta make sure they're x's. And then we've got to do another set of ands basically. Let's just sort that out. For the y-axis. Y, and y. So here we're going to output where they start and end and actually see the values, but only for the mouse is. So that'd be pretty cool. All right, here we go. So if I freeze it there, we can now look. Right, so apparently there is nothing there, apparently. But there should be. But according to this, there is not. So potentially what's happening... No, it can't be that we're not putting them in there. That's just incredibly wrong. So... So what happens if we didn't fill in the gaps? Does the fill in the gaps shader mess this up? Because now that we mem set them to U32 max, they should still be, yeah. So that's another thing, the new thing to test, is if we disable the shader entirely, because the entries start indices are cleared to U32 max, the new system means they will still not show any good value, because when you fish it out, it'll be U32 max and gets minned with a max value. So these will still show 0, basically. And yeah. Right. So what we're discovering here Why has it got such a big value of things? There, that's interesting. Right, so still seeing weirdness, but it's not as much. There's still holes, but there's not as many holes. But if we hover over some of these, they've got like a really big value. I forgot what that means. So there's a range. Oh shoot, what the hell is this doing? Spheres count. So it shows the range, and then it shows the takeaway. Oh my days, okay. No. So it's saying the start. Right, so these ones have a big value. Actually, the start is after the end. That start index is bigger than the small one, which is incredibly wrong. How can that be possible? So clearly something is wrong in the initial shader which sets these up here. So that's very weird. we pick up the pair. Pick up the pair of sort keys. We'll look to see if they're different. Let's see if the two tiles are different. And that means us define the start of the array for the tile entries. Then we go over all of the tiles that span. Wait, is that a good idea? Yeah. Because there's only one instant in the array, so this would be safe. So we start from this +1. Yeah. There's start +1. Yeah, this looks sensible to me then. So why is an index after, unless it's not being sorted correctly, which is very strange. I guess we could do a dump. We could dump this, but we could dump it to the terminal. But why don't we dump the first 1,000 elements and just see what they are. So I want to know like GPU, pageprintf. I want to basically say this entry is at tile. So if pair start index is less than 1,000, then what I want to know is I want to say this index is at tile index, this one, I think. So we'll go pair start index +1, 0, and then that'll be equal to tile index 0. I wonder what I'm doing wrong here. So we have some printing there, which would be nice. Right. Maybe we should disable the other printing though. No. Okay, so you got like 64, you got some zeros here, so they're all on like 39. Tile index 39 has just chucked itself in there. Then there's a gap here. 768 goes to the next tile. These are the entries for 768. Sorry, for tile 380. Then afterwards, we've got some 737. Oh no, that's fine. That's a different bit before there. That's fine. They're fine. Right, so the first 1,000 seem alright. I think this code is actually fine. The problem was when I minned it. I think that was the issue. Because we minned it with the end of the array. One of them was an invalid value, therefore it. Or how do we pick up when it's an invalid value? So what I want to say is like, if this is less than the max value, then we only... Right now we're still getting those weird numbers. That show up in there, then alright, here we go. Yes, when we hover over these now, they're not showing any data. But this one is. So this has got valid values. These guys haven't got any values in there for some reason. This ain't good. Right, let's put it around this where it's making it go blue. Okay, so now what we're seeing is only these guys actually have spheres for some reason. And are we filling up the array? Is that what's going on? Are we filling up the number of spheres? There's not a lot. There's only there's only like 8,000 or some, or 7,000, something like that. Oh, there's a 9,000. Oh no, there's like 53,000. Whoops. There's 9,000 in that one. Okay. So we're starting to see... Right, so I wonder if we're actually filling up the array. So how many spheres have we got? What's the spheres cap? It's like 200,000, isn't it? I think so. No, it's 2 million. So we've got plenty in there, right? Right? Right, it's all old. Yeah, we've got more than enough room in these arrays. Is the sort thing high enough? Because there's a sort capacity thing. No, that's 1 million. Yeah. So it only had 90,000. So 90,000. I think the problem is now, like, maybe it's the binning code that bins it into the screen tiles, maybe. Prepare spheres. This is the new one that we made. So I think the issue could perhaps be in here, but it should be adding them in. So maybe there's something wrong with this code, perhaps. So we're gonna debug this in a minute. Right, I'm just gonna take a quick break, and then I'll be back, and we'll look into this. Right, BRB. Hello everybody, welcome back. So I've got a good idea that can help us debug this problem, and we'll just use the mouse position thing again. So I think we can, where we use that mouse position to do the debugging, we can do the same thing again. We're going to simply print out whenever a sphere, I don't know, actually maybe that's quite a bad idea, because there might be so many entries. But we at least want to say, yeah, because if you've got tons of spheres, it's just gonna, yeah. Maybe we can just read it first. So, yes, if the sphere is not occluded, it's going to go ahead and make the sphere. It's going to do an active sum to figure out how many waves are here. Active waves we've got. That's how many spheres we're going to add. Star index will be this. If it's the first lane, it's going to do the atomic add, this number here. And then we read it from that lane using a wave active min. So all threads within a wave have the same one. Then we do the star index plus the prefix sum of 1 to get our unique index and insert that in there. That seems fine to me. Now I copied this from another place, so it should be fine. It just basically translates the bottom left and bottom right into a, what are they? Yeah, they're signed vectors. Signed 32-bit vectors. So bottom left, top right, it's going to take those and turn them into bottom left, top right tile coordinates from pixel coordinates. And then we simply get a fixed point depth value, calculate all the tiles that we're going to be writing for this thread. We're going to sum all those boys up, do the same trick again on the entries, add them all in, do a wave active min, then a prefix sum for this thread to get where they start. Right. And then we go over all of our tiles. And then put them in the array with the sort key. Now that seems sensible to me. So it feels like there's tiles that just get missed though. And I don't know where it's coming from. Because so what we're going to do now, I guess, is print out every pair that we find. And then with that, we can use the mouse coordinate to also find. Yeah. So I think I can do a GPU hprintf. I want to say tile index starts at blah, right? We'll put that in there like that. And, hang on a minute. Did I just bugger something up? Here, no, that's fine because it's index plus 1. Yeah, that's right. That's 100% correct. Right, good. Okay, so we got that, which gets printed out. I also want to find Oh, whoops. Yeah. I also want to do make sure we put the tile index on that in this print as well. Tile index blah range. So I really want to put the tile index in here, and then I also want to say, you know what, only bother doing this if this is the first wave is first lane, because we're just getting spam into the or thread. We're getting absolute spam. Yeah, I don't know why I called it first lane actually. I need to call that first thread, because the terminology we've got is we don't use the word lane, we use thread. But that needs to be done as well. Let's jot that down. Rename wave is first lane to wave is first thread. There we go. That's in the docs now. So let's have a look at this. Right, clearly there's a ton of stuff being printed out. Too much actually. There's clearly too many tiles. Maybe we can move the camera back a bit. I think that's a big problem. We keep having to step back. So or maybe move the instance. Volume instance. Put it 128 away instead. Let's try that. There we go. Right, this would be a lot better to work with. Right, so what am I trying to find again? So I'm printing out this where it has the range, that comes from the where my mouse cursor is, and I'm also dumping where the start ranges are. What am I trying to find again? Yeah, I'm trying to be like, right. So have a look for this 6-2. Alright, so there is a starts at this number. That number is the same. And I guess there's one that comes after it. Right, the one comes after it starts there. So there's a lot of entries in that one. What about 2-1? Okay, 2-1 is not a valid one. But 20 is. I think we saw when we looked at it, there was not one which was 2 before, even though it said there was, which is a bit confusing. This should be just filled with okay, there's another problem with my debugging. In the tiled ray tracer, we only really care if the start index is invalid. The end index, we don't care if that's invalid for this debugging purpose. Because we just want to know if the start index has been set. Still though. Right, there's more now, I think, but still. Like, why isn't this one got any spheres? So if I hover over this one, we'll get the number. It's tile 579. Then 578 should not be set. So 579, we'll see it gets set there, right? Now let's do 578. Yeah, it's not set, but 577 is set. Right, okay. So at least we're seeing some... Right. Okay. So... What's the biggest kind of value we have here? Guess the next question. So we've got like 300,000. I've only got 1,000,000 that we can sort, but I'm not seeing any issues. Yeah, so 300,000, only 400,000, but yeah, so we've got like an array for 1,000,000, so that's fine. So it must be to do with the way it gets binned or something. Trying to figure out a good way that we could check how we do that. We could track. I guess we could just do the mouse position thing again. We could do the mouse position thing. And say, hey, if you found one, here, spam out in the terminal. Yeah, screw it, let's give it a go. We're going to try this. So given a tile coordinate xy, mouse coordinate xy, if we're in that range, then I want to print out and say like tile whatever got sphere. Yeah. Let's give that a go. That should hopefully enlighten us on the problem. There's way too much stuff. There we go, okay. Right, so good. So we do go... Oh, that's got some stuff, but it's not showing up. Right, so it's clearly saying here that 581 got a sphere. Right, when I hover over it. But if I go here, it's not going to say 581 in the array at all. So I guess what we're doing is overwrite. Some data is being overwritten or something like that. So do 589. 81, I forgot what it was now. Yeah, 581. We're not seeing it show up in any thing. Why is that? We've got 12 bits of information. That's obviously well within the boundary. That's only 9 bits it's using. Or 10 bits. 12 bits you've got. Yeah, about. Yeah. So you've got plenty of room. So that's your max number. So that's fine. Well, it's something to do with this, I imagine. So, how many tile entries for this thread. You get the width, right? So it's the right, take the left, multiplied by the top, take the bottom. Right, top being bigger. No problem there. The wave active sum gets that all into the same, same value across all the threads in a wave. Here's our start index. One thread does this. Hey, yes, how's it going? Not possible to reduce the scene to more manageable size at 2 tiles with 1 sphere each. Maybe. Probably not. Because we can't space our spheres out like that. I know what you're saying though. Yeah, to reduce the... Yeah. We can maybe use a lower level of detail, but I haven't got that plugged in yet. Yeah, I could switch down to that. That's not a bad idea. Yeah. I could just say, hey, only render LOD. Yeah. Definitely a lot easier. Yeah, I could do that. We'll try that if we get stuck in. That's a good idea. Thank you. I should be able to hard code a level of detail. It's going great. Always nice when you're streaming. Thank you. Thank you. So you do a wave active min on that start index into itself, which is fine. Then the start index plus a prefix sum of the one for this thread, right? Which makes tons of sense because you're basically saying unless my prefix sum is not working well. I don't know, right? Um, 2, 3, 4, 5. Perfect. That's 12. That's good. Right, it's checking to make sure we're not overwriting. It's 12 bits. Of anything else. It seems okay. Right, let's try your idea out. Let's reduce the number of entries. Then we could probably debug, print. Yeah, we could get like a handful of spheres. So if we do LOD 0, where's the clusters? We have to hard code it in 2 places, though, right? Prepare clusters for render. Yeah, so if we comment, we'll just say, hey, the first one to get some form of spheres, just put those on the screen. So the first LED that has spheres, just use that one. That's what we'll try. And that should all work out the same. Right, so we should have far less data now, I think. That's a good idea. Yeah, so only got like 131 now, which is like much more manageable. That's good, that's good. So now we can probably just debug print all of the spheres and know how they get binned. So we can say we can literally just print out the ranges, I reckon. Let's just see what ones they get binned into. and just see if those overlap. So I put my mouse over this tile. Right, there's a lot of ones going to 69. I did not make that up. Oh no. Right, that starts at 69. Right, at least they're all different there. Tile index got sphere. Okay, so at least they're all different. Right, it's not this mouse curse thing anymore. I don't think that's a good one. So instead, what I want to do is say, I probably just want to say sphere, print out the sphere, and then probably it's ranges of tiles. Yeah, probably it's ranges of sphere going into sphere this number going into this to that. The sphere index, that sort of start index. And then probably add to it the number of entries for this thread. So we try that out. We should see, maybe be able to see some overlap. Right, clearly got a lot of, I put a new line in there, what's the problem? Oh shoot, I put the sphere index, so it's reading garbage data when it does the printf CPU side. No biggie. Right. So, now what's the sphere going into thing? Interesting. There's only, yeah, there's only 8 spheres. Right, so it's definitely picked a very low LOD. That's cool though. Fine with that. So do these overlap? No. These don't overlap, but still, we're getting holes. Is this an exclusive range or inclusive? That's the big problem, if not, isn't it? I think it's an exclusive. And also this one needs to probably do a... You're right. I'm muted. Oh no. No? Shouldn't be muted. This is moving here. You hearing the music as well? Hey, Moscow. Oh, this is a bugger of a problem. Let's get some H to it. So the 8 spheres Why are they not? Binning. No worries. Thank you, thank you. So I guess what I just want to say, like, X range. I'll do a Y range as well. Of tiles. So we should be able to see. I think it's an exclusive thing, because I quite like the exclusive ranges. Inclusive, I barely do that. You know, they're the X, the Y's, only put the X's before that. I'm not sure how I would be programming without all this printf stuff. It's definitely a great feature. Right, so here's the ranges. I had this in, oh, X range. There you go. 16 to 19, just 3 tiles. Apparently 2 tiles. 2 tiles. These are like 2x2s basically. Maybe what we need to do. Where's this sort of thing where it just starts? Let's comment that out for a bit. So we're only going to see this on the screen now. So we can hopefully move the window and do some debugging. Right, what are these Tetris blocks doing here, right? So apparently this one has it. Oh, for crying out loud. Right, it's a range of 2 and a range of 3 or something like that. I'm not down the Y. So where's the 2x3? I don't see a 2x3 here. There's something really strange going on there. Already. Like, it seems like we're missing stuff. When I see a... So I don't have any tile indices to know, but... There's only like 3 spheres, right? Or whatever spheres. Why is there 91 entries into the same... Something weird going on there as well. Yeah, thank you. Yeah, I'm just trying to debug right now. So I've got a lot of debug stuff up. This is the occluded texture. It's not really needed right now, but I've just left it there. These represent where if our screen tiles have spheres in or not. And when they have spheres in, we can do the ray tracing, enable the ray tracing code. This is debug drawing for the volumes, and there's a screen bounding box and the view space bounding box. But yeah, I've just and there's the orientated bounding box. But this is just being drawn over randomly by stuff at the moment. Right, so something really skeptical in this tile index that has like 91 entries in there. Why should there be 91 entries in a single tile? Nine two one two two. Sorry, excuse me. That's because we did the end. The end index can be set to the end of the array. And we are just deep. Okay, that's fine, that's fine. That's okay, ignore me. That's me being dumb. That's not something to investigate. What's the thing to investigate next? So, why are these things? So we apparently put 112 entries into that array. That binned entries array. So maybe we should debug print all of those. And then maybe see what it contains after the sort. Something, I don't know. Is my sort, you know what it could be? I was thinking it could be something to do with this whole binned entries count. This being wrong, but it's not. That's the number we put here and it's exact. Should be exact. Everything should be filled in. So I guess we can print that next. Yeah, there's a random on the bottom left. Yeah. That's at index 0 for some reason, and I don't know why that is either. Yeah, bit weird. So we just want to say entry. For crying out loud. Entry this. We want to say if got a sphere of that value, and we probably want to say we're inserting it at tile index. Should we do an index or coordinate? Maybe an index. I don't care about the depth for now. Yeah, it's just putting those in. We just go entry index, tile index, sphere index. There's none in there apparently now. Like what? They've aligned perfectly, so there's apparently none that the screen has. If we look at all the entries here, we can look at sphere 4. I don't know even what I'm looking at now. What's the good idea? I guess you want to try and see if there's any overlap between some of the numbers, or if they all get filled in. Yeah, problem is they can't be sorted. So we can look at the. Right, so here's the before. And we can do an after entry, I guess. And then we can take that data. So here's when it tries to find the start index. So we can actually print out all of these now. After entry. So that's pair start index. Plus 0, plus 1. 0, 1. And the sphere index, we just grab that from the other array. I don't have access to it in the shader, unfortunately. But maybe we'll leave that one out, actually. No. We shouldn't leave it out, damn it. Right, we'll put that in there correctly. Indices. So I've got to, from the CPU side, also throw that boy in to here. Okay. So now we should be able to see a before and after array. And see if they're actually being sorted correctly. And there's only 100 entries to look at, right? It's just at 200 to look at manually. It's not that bad. Let's take a look at that, for example. Right, they've all got sphere index 0 for some reason. That's strange. Quickly double check. Should be correct. Read only. I've got the right buffer in there, right? Oh, it's the setup one, damn it. Crying out loud. 2 seconds. Right, I'll run that again. Still getting 0 in there. Alright, seems okay. Yeah, maybe the sort function is not... Oh, there you go, yeah, it's showing up fine now. That's good, that's good, that's good. So we're going to cut that off like that. So apparently there's 90 odd entries or whatever. I don't know where's the best bit to take. Probably from there. And we'll take this into the editor and just have a look at this data. See if we can reason about it. So I guess if we say entry 53 before then. So before, it's in tile index 536. And afterwards, it's in tile index 656. So there's a problem. The sorting is actually messing. Oh wait, no. No, of course, no, that's fine, that's fine. Yeah, of course, it messes with the order, that's fine. So we can't really look at an entry, if you will. We've got to look at the actual tile index 536. Does it have a sphere? It has a sphere 0, 1. There's a 1. And in the after there's a 0. Okay. Maybe I should debug draw these spheres as well. Maybe that's a better way of debugging this. Entry. So 540 has... Yes, the sorting, I guess... that's another thing as well. We want to see if the order... It's hard to really get the order because there's a bit of spacing, but after it should be sorted where the lowest tile index appears first, and it does appear to be that way. No, you should never see one that comes after in the entry index have a higher or have a lower tile index than the one before it. That does seem okay. Yes, I think the thing I want to debug next. So I think the sorting is probably okay. Maybe we'll comment those out for a minute. Is we've got debug drawing, so why aren't we using that? Let me disable the depth buffer testing thing. Oh no, we just won't depth test it. Yes. So I think I'll like draw 3D sphere. We can draw it in view space, and we have all the view space stuff right here. So we should just be able to say, and we can also draw the tiles in screen space. So we can actually draw all of the tiles that are actually getting affected. This is probably the best way to debug it, I think. So we want to say radius, there's a sphere radius as well in view space. I think there's a color. We're going to color ray, is that it? Color then Z test, right? Yeah. So we'll do like a color white. Why not? And then false for Z testing. Now I've also got a 2D drawing API. So we can actually do that here. We can simply say, okay, draw 2D. I think I got an access line banner box. ABB, yep. So we need we want a min-max one. Oops. So min-max. So the min, one of these would be x multiplied by the tile dim. Yeah, tile dim. Then y times tile dim. Then the end position is going to be that plus 1, basically. So plus 1, and then a sort of like a plus 1 there. What are we missing? The 2D ABB is, there's a depth value, doesn't matter because they're not overlapping. Border thickness, we can put as infinity. Depth value, whatever, 1. Infinity. And then, what was the other one? Color. So the color, we could do something like, we could color them based on their, I don't unfortunately have a hash function, like a nice way to color it there. Quickie's way to color it. So I think we can just pull one off. We should definitely add a hash function. That's another point. Right now, I'm not inclined. But yeah, so we probably want to do something like x. Maybe addition is probably right. X plus y. Then probably multiplied by some big hash. Where's the FNV hash that we've got? That would probably be good enough. Yeah, one of these guys. That big prime number there. Well, they're both prime numbers. Just one of that. Just multiply by some prime, and then we'll like OR the alpha bits on, right? And then that should be a rough color that we can just use. So that should Oh, right. But that's going to put all of the spheres on the screen and light up everything probably. But let's just see it. Oh, that's nice. Yes, that's what we're expecting to see probably, something like this. These are where they are supposedly are. Um, like we've not got any of the bottom apparently. And also, where are the spheres? I don't see them. Oh, they're behind the right. Let's remove the tiled thing for a second. Right, here they are. Here's our balls. So it's a 2x2. As you're seeing with this, they are kind of getting binned in correct spots probably. So run it loud. Get out of it. Okay. Yeah, so as you're seeing, behind here there are the spheres, and these are the tiles they're getting binned into. At least we think they are. Yeah, so they are getting binned into the correct then. So it must be my other code. Sure. So let's keep that drawing code because that drawing code is quite nice. I think I want to disable it. I want to move it now to where we find those start indices. So this is where it finds the pairs, right? So why don't I just take that and reproduce an XY coordinate and just light up the ones which where you find a where we find a hmm. Yeah, ones where the start index gets set. Yeah, let's do that. So here we want to fold out the x. So that'd be like index, that's the tile index. So you want to basically mod that with the grid dims of x, right? Oh my days. And then for the y, we want to divide it. It's basically good enough, I think. So now we should be seeing debug drawing of the tiles for the ones where the start index is set in the array. Right, why are we seeing them all across here? That is definitely skeptical. Like, why? Oh, it actually goes all the way across. It actually likes to go. That's not good, is it? Oh, no, that's probably fine. Yeah, that's fine. Because it sets them to the same value. Yeah, it's completely okay. What about the last? We should probably do the last one, actually. Alright. So instead, let's only debug draw tile 1. So it finds a pair in the sorted array, and when the tile index differs, we know we're at the start index of the array of entries for this tile 1. So this are all the tiles where they get there. And they are exactly the same as the blue ones. No surprise. So as you can tell, there's blue ones. There's like a pixel for like a blue. There's like a blue outline, but I don't know if it's exact. It does seem like it's exact, right? It's blue. I can see the blue. Okay, so is something wrong with this shader then? Like, but how? Like, why have we filled this up with? Like, are they just not sorted? Um. Or are we not visiting every element in the array? That's the other problem. What could be the other problem? Is we're simply just not visiting every element in the array. Like, uh, I could have a bit of fun and just debug draw this. How many? Do we know how many we're gonna have? Yeah, this is like 200. Oh, we have more than 200. Wait a minute. Yeah, we have enough tiles to fill that. So why don't we just like have a bit of fun and instead plug this into this sort of debug drawer. And if we see any gaps in the tiles that start from the bottom of the screen going up, then we know there's gaps in... Oh, no. There should be a one space gap because you do two pairs at the same time. I don't know because we're drawing on... Sorry, did I put this in the wrong place? I put it in an if statement like a Wally. 2 seconds. Eh? No, there shouldn't be any gaps. No, we know we probably know there's a good amount of... We probably know there is enough tiles. Or enough of these being dispatched. We could debug draw all of the tiles that we go over actually. That might be another one. It's probably a good one. Let's do tile 0, index 0. And then tile index 1. So if we're seeing the same sort of thing when we did it up here, then at least we're going over all the entries. At least. Yeah. So at least we're going over all the entries. We know that for sure. There's just a weirdness between the logic of how we're defining the start and end of... Okay, so we at least know we're going over all the entries. Could there possibly be, if that is greater than this, have we got some issue where they're not actually sorted or something like that? Oh. Right, so I don't see any whoops showing up on the screen at least. There's no whoops. So they appear to all be sorted in some way, if not the same. So we know that every tile definitely gets visited. I guess when there's a difference. Let's only do this when there is a difference then. See if that. Oh man, I've just realized the mistake. Alright, here's the problem. We're not interleaving our pairs. Right, so you got an array. Right. These are all our tile binned entries. What we have, say, is 3 here. This is tile 0, and it's got 3 entries. This is tile 1, and it's got 4 entries, right? But we need to find where these boundaries are. This is what this shader does. Now, the way it's doing it is it's checking over 2 tiles, two pairs, and seeing, does the tile index differ between these two? Because each of these store a little tile index in there, basically. It's actually in a parallel array, but I'm just saying it's here. Right? If they differ, then we've found the edge. If they don't, we carry on. And then we check these two. Right? In this case, it works out fine. But what happens if the number was even? And do something like this. And then the next one would do something like that. You would miss the edge. You'll miss it. So the problem is I need to interweave these things. So what I actually need to do is dispatch over everything, probably take 1 amount, right? And then you would solely be looking at comparing me with the next one. Yeah, so it's pair start index, do the checking there. Man, I can't believe. Right, that's good. So that should work. Yeah, okay. So if we debug render that now. There we go. Smothered in tiles. Just what we want to see. Why am I not seeing anything else? Probably I don't know why I'm not seeing anything else being debugged drawn. Maybe I filled up the buffer. I don't know. But cool. So we're seeing it now. That's good. Okay. That's cool. That's really cool. So this is fine. We had this fill in gaps thing that we didn't end up we ended up disabling. We definitely need to enable that now. Fill in gaps shader. So if there's a gap, there might actually be a gap. This actually might be tile 2. Right, so tile 1 doesn't have a start index. So it's actually set to U32 max, like all the way off the end of the array. So what we're doing here in fill in gaps is we're saying, hey, look, my tile index. Oh, what am I doing? Yeah, search, look at my buddies to the right of me and keep going. And if they have 1, set mine to theirs. So then my start index would be the same as 2. But when I try and get the size of 1, how many's in 1, it's going to be like, well, mine starts here, and then it ends where 2 starts. And if 2 and 1 start the same place, it's got a size of 0. Or the number of elements in one's array is 0. So that's what this does. Alright, so now we can carry on. So I think there's only one more bug left to solve. Sweet. Blues. That's what we like to see. Where did my OOBB go? I don't know what happened to that. Are we rendering the other spheres then? No, it's there, it's just the depth buffer's not being rendered. Oh, I see it now. Right. Anyway, so... Okay, so that means now there's only one more problem. This lower left one has got a range of 0 to 1. Why? Do we actually bin anything in tile index 0? We set it to 0 here. Oh, right, that was the problem, I think. It's because we set this to 0 here. Probably it. Sweet. I think there's some real bad issues here though, like what is that? Yeah, I don't know if the game's gonna crash if it goes off screen. Oops. So if it goes off screen, could this cause any problems? I thought we clamped it and all of that. But I can't, yeah, I gotta make sure we're not seeing any glitches with this because if not, our ray tracer is gonna access invalid memory and it'll just crash the game. So, I guess we can start here, right? Debug draw the tiles. Oh. Yeah, debug draw the tiles. Great, so if these go off the screen, then the problem is here. Alright, they do. So the problem is in this for loop. So it's the way this gets made then. I thought these were signed. So it's that divided by that. Right, so it just truncates. Right. It's the top right. It's this one. We didn't do that. So I think we do this in another place as well. We do this with the clusters, I think. Do we? Oh no, don't do it with the clusters actually. Right, okay, so that was the problem. We didn't do the signed thing, so it was wrapping, I think. Right, that's good. Still a problem when it goes near the top. Though I think that is to do with... It gets bloody slow. I don't know. So what is it doing off the screen? Right, I'd like to hope that it's not to do with my ray tracing code. I guess there's one way to figure out it, which is don't call any of it. And then if we disable all of that, I'll disable the ray tracer. Do we get a lag? So is that coming from the prepare clusters shader? Hey Ross compiler, will you ever get to game or are you working on features right now? Doing ray tracing. I'm trying to find the graphics art style. So I'm just trying to see. Right, it doesn't lag here when I do this. So it must mean that it's in one of these shaders. So we'll slightly enable them. So effectively we're trying to find a graphics art style. So I'm trying to see what I can do with spheres and how fast I can render a bunch of spheres. And then when I know how I'm going to render the spheres, the next approach is to make them look good, right? And then after that, it will be probably think about. Well, I already know the tooling I want basically, but then it will probably be think about try and settle on a game. Because right now I'm just building the essentials that I'll need for any game, basically. Well, not really any game, but yeah, 3D game, and you know, with the requirements I've already set by building what I've built. And then I want to look at that game design idea that I did in February, and see if that's the one I want to do, or maybe I want to come up with maybe 2 more ideas, and then yeah, settle on the game idea and then plan out how I'm going to achieve it. But yeah, I want to do a unique art style first because, yeah, I want to find that first. Because graphics is a very complicated thing, and I want to have that figured out first. Probably a lot of work behind the scenes I don't know about. Sorry for asking directly. OpenGL, it's easy. Yeah, well, it's not necessarily easy. Like, it depends what you're trying to do, right? What we're trying to do is very GPU driven and not and kind of do something that's very unique. And when you try and do that these days, it's quite difficult. If you're just doing stuff that people have already done, and you know, it's a lot easier. But graphics programming is still not a walk in the park. There's still lots of things to fight and get right, and debug. But yeah, trying to do it well definitely takes a lot of practice. So is it to do with this prepare spheres one, right? Is this the shader which causes the slowdown? I guess I could have just enabled the right, this one it just disappears around there though. Oh, that's fine actually. Because I think that's to do with the that's not to do with that shader, it's a different shader. Is it to do with the sort shader? Oh. Is it to do with the finding starts? For crying out loud, it is. It's that it's this one here, isn't it? Oh no, that's not even the fill gaps one. Really? Why is that one slow? Right, let's enable this profile. Let's see some times. 77 milliseconds. On find starts when he goes off the screen. Why? How many of... Oh, what? Why is find starts like piece of work? Like we've got no printing in here going on or anything. And if you go off the screen, does it put in... Is there like a lot of iteration that's going on? Oh, you got nothing in the... Right, so when you go off the screen, let's disable the... Do we get any entries that go... I'm thinking that maybe there's entries that get put in the array but they're not being shown. Alright, there's 0 entries in the array. Ah, that take 1, like a melon. So we actually don't want to launch it. Oh, we can. So we want to max this with 1. So I basically just said, hey, launch, 4 billion threads. As you do. That was the issue. There you go. So it doesn't launch. When it has none, it doesn't launch. There you go. Good. So I think we just found all the edge cases now. Let's double check that. Let's re-enable all the bits. Starts. We're going to find the starts of the arrays. Let's just double check that. At least so it doesn't like go full on crazy like it was doing. Re-enable the ray tracing. Disable this lovely debug tile thing we've got. And that was good. We need to get a hash function on GPU so we can do more nice colors like that, because these colors are just obviously not as pretty. Okay, so I'm liking where we're at now. So I think we should just be able to plug in. It's fine. We should be able to plug in the all right. So can I double check what all right. So with these max entries, you're minning with the end value. Yeah, so if the spheres count is 0, we basically just want to end anyway. And don't render anything. Alright, let's try this out. So the stream dies, I'll be right back, but it should be alright. Here we go. Boom. So we got our ray trace spheres back. That's good. We're not seeing any depth value though. Wait, what's going on? Why are we seeing stuff that... Right, some tiles are trying... Okay, those disappear, that's fine. We can sort that out another time. It's not the end of the world. Right, let's bring back more spheres. And then I guess we can improve this ray tracing code. Whoa, Benno Montana, thank you so much, sir. How's it going? Yeah, not doing bad. 29 months, thank you so much, sir. We've just been fighting a silly bug. And we found the silly bug. We've been doing a new tile binning strategy to tile bin these spheres. And we just got it up and running again. I'm just going to enable the higher levels of detail now. So we're about to go and sort that out, and then improve the quality of the rendering by doing proper anti-aliasing. There's something to do with the depth buffer as well. Did we disable that? We didn't disable depth, right, did we? Well, it was now. Oh. Here it is. Right, so this will mean this will do the proper LOD selection now. B, how's things going? You been, Montana? How you been? How you been? Right, if the stream dies, I'll be right back, but you know the drill. Here we go. Oh yeah, we're in business. We're back. So now, right, as it gets near the top of the screen, the culling is bad. I don't. It's something to do with the prepare clusters for render. But what you can tell is the occlusion culling is working, right? Here's the occluders, and see here how we're getting like the edges, but not the insides. That's because it's successfully culling those. And when I do this, they come back, right? So that's cool. We put the depth buffer in as well. The depth buffer though, something is wrong with the depth buffer. Oh shoot. No. Oh, did we survive that? The stream survived. Excellent. Oh, sometimes that will destroy the GPU. We got some. Yeah, some of the depth buffer, I think. So glad to see you still going strong. Yes, I'm fine. Very busy. Just tested my dual monitor setup. Spend more time on SD stuffs. Cool. Nice. Have you had a dual monitor set up before? Then have you got two of the same monitors or different monitors? Right, so that was super freaky. I don't know what happened there. So we look at the ray tracer. What do we do with the depth buffer again? Do we still right into it? So we still do everything with the depth texture, I think. Right, let's enable this on by default. Maybe this will cause more problems. Let's see. That's looking really bad. What has messed up now to cause that? Why is the occlusion texture not... So the occlusion texture gets the reprojected depth. The depth buffer, is it not getting a clear? Depth texture. There used to be a clear, right? Oh, no. We guaranteed that the ray tracer wrote every pixel out. That's what we guaranteed. So the clear is happening in the ray tracer, since the first time we write pixels to the screen is the ray tracer. So if this happens, you need to write out to the depth texture an infinity. And there's the problemo. Right. Very good. Went all in on this one. Wait. Not really. On my laptop, I used to have this crappy setup. I have two identical LG 4K. Nice. Awesome. I only have one monitor and it's 1080p. You've got like that like I don't know, 8 times the amount of resolution I have. Insane. Do you ever think of this game? I have a design. I haven't really gone over it on stream. It's in the repo. But there it is. We get some glitches when we move because we're using the depth buffer from the previous frame to occlusion cull spheres and clusters. But we're not worried about this. We're not worried about this because we're just doing performance testing right now. I want to improve the anti-aliasing though. It's terrible. And we can do that today. We've still got time. No. Please don't crash. Okay. Thankfully, it seems like the AMD driver's fine on this one. There's some really wrong goes on the... We back? Still here? Did I just... Oh, fine. Good. But yeah, theme-wise, I've got a design document. We're going to look into that after I've done this rendering R&D and see if that's the one I want to do still, and probably design a couple more games and think about how much time I want to spend on this project and everything, and get a plan towards that. But yeah, right now it's just R&D on how I want the visuals to look, basically, and how we want to build the 3D assets. I already know how I want to do that, right? I want to build some editor and that, but for now, I just want to guarantee the rendering technology is what it's going to be. So I need to just figure out that first. So we're just trying to render a ton of spheres, get these volumes, see how many volumes we can render, make them look reasonably good. Yeah. Right, so what could be the issue now? If your pixel goes outside the screen, that's not a problem, obviously. Then you get a tile index. If your star index... Oh. If your star index is an invalid value, but your end index isn't an invalid value. No. That should always be true. That should never happen because we've got that fill in the gap shader. There's something wrong somewhere, because if it goes behind the camera, maybe it's filling up the array. It's hard to tell. But yeah, I guess we just won't put stuff behind the camera for the moment. Just be careful about that. So let's just improve the ray tracing quality for now. So the problem you'll notice, it's not flickering anymore as much. Yeah, it's not flickering anymore, but you should see there's these black. Oh, wait a minute, I need to do the same problem again. Bugged it up. Right. So you should notice. The anti-aliasing is messed up. It's just not good. There's these black holes that appear. And is what was flickering previously before we did this rewrite. But now that we sort them front to back, it's not flickering anymore. But it still looks terrible. And we need to do the early out system as well. So what I want to do is basically just adjust the ray tracing code. So we're going to get these black pixels, right? So it's quite easy. We've got a screen coordinate, right? We've got a ray direction going through the pixel. We delete this code because we don't have the old occlusion texture. We've got a new one. So we did a lot of the debugging in here initially. So we're going to be doing removing some of that. So we're no longer looking for the closest near miss. We just process the near misses in order because our spheres are sorted front to back now because we've sorted them. So it's really great. So now there's just a closest hit, like an opaque hit. There can be transparency in the future. Not yet, but we can do it. We need a normal, a color, near miss. We don't have near misses anymore. Wait, do we have near misses? No, you just accumulate it. Near miss, normal, that all goes, okay? So we've got a color. So do you want like you need to do the blending. Yeah, so you actually just need a color like that. Right. So you go over all your spheres in the tile and they're sorted front to back. Okay. So basically we do a Raver sphere, right? And if we hit it, and there's no longer this closest depth thing, but if we hit it, like a full-on proper hit, I guess there could be transparency here. So I guess we could write it. There's a color, I think. I think it's all color. So I think we say color 32 because it's packed. Hey, I think you do that. Yeah. So you just say, hey, get me the alpha. If the alpha is equal to, well, you always want the color as a so you probably want to call this the final color, I don't know. So you get the color, which would then be the sort of like unpack UA, right? So unpack that color 32 into float color. So now what we're looking for is do we want to do the unpacking always? I don't know. Can always change it later. So if the alpha, yeah, we always want to do it. So now we want to do some sort of like front to back blending. Now I did this before and I forgot. We do it in the UI. So here's the UI. Where's the so we've got some crazy virtual scientist field virtual machine. Because we can. Because we can. Right, the default color is 0, so that's what we want to know. So we need some sort of front to back blend function. So you're basically going to blend it front to back. Final color with color, and voila. Now we want to say, okay, if where the final color alpha is fully opaque, then end here. As this is an optimization, we just where we don't trace against any more spheres because it's not going to contribute to the final color anymore. So this is saying if it didn't hit, right? So I extended this rayverse sphere, and I basically have an extra boolean to say, find the nearest hit that lies in an acceptable range. So yeah, so what I want is a complete miss. Yeah, that's what I wanted. So I modified it so if it simply was, the sphere was too far or too short, it still kind of hit. But if it's a miss, so if it's a complete miss, we basically get the, we're effectively got a sphere and array that goes like that. We check, I think the way it's working, let's just double check. Yeah, so we take the pixel size at the near clip plane. So you got the near clip like that. So you got a pixel size here, and we project, well, we scale it to, so we take the center position of this, so we do some basic trigonometry, right? And we trying to get this, we get this vector here, this one here, and we're trying to see if this distance here is basically a pixel, if it's less than a pixel size. And if it's less than a pixel size, then we can do some anti-aliasing based on that. So we're with a pixel that should AA against this thing to some degree. So what part of the game is run on the CPU? Do you... Yeah, all the rendering code is done GPU. I don't think I'll do anything game-wise on GPU because I probably want to use it all for rendering. Yeah. Because I'll probably do some complex stuff. So what I drew is basically all of this code, right? So we get that's the hypotenuse squared. We get the squared length, so we avoid the square root. Hypotenuse is this boy, right? We then do the dot product of the origin to sphere. Wait. Oh yeah, sorry. Yeah, we dot it across. Yeah, then we dot it the depth that goes. Yeah, so this has, we basically reproject this across here. Just in how long does it go across there? And we'll get this point here, basically. And then we can do some magic. Wait, hypotenuse, I did the wrong one, didn't I? Hypotenuse is a different one. Squared hypotenuse. Is that... This might be the hypotenuse. Maybe I got that wrong. Alright, let's get my... So for like a right angle... Oh, it is right. There's the hypotenuse. Let's point to the right one. Is that the opposite side of the opposite? Closest point on ray, distance squared. Closest point on ray to the... What have I done? So the length of this edge here... Wait a minute. Sorry, I did the wrong one. I drew this wrong, so it's confusing my brain. This is the right angle. This is the hypotenuse. Right, so the length of that squared. Okay. I see. So it's the length of that squared. We reproject that length onto this vector. So then we can get this point here. Is that right? No, we get the length at least across there. And then this edge, this distance. Oh. Hey, not so red. Yeah, things are good, man. We got the ray tracer plugged back in, just sorting out the plugging back in the alpha blending. When I did it, when I from back when I had it sorted at CPU side, all the spheres sorted front to back CPU side. Now it's all done on GPU. They were just plugging things back in. So it should be a lot more simple when we get to see the performance in a bit. But yeah, how's things been with you? Have you had a good day? So just trying to make sure this is correct, this anti-aliasing code. I think it's correct. I'm just trying to double check, rediscover how I did this. There's the hypotenuse squared, then reproject it across there, we make a depth squared. So we've got these two lengths. So if you take these two lengths away from each other, you get this length, I guess. Length of this guy. So it's the closest point on ray to sphere distance squared. That makes sense. But then I think this is just a bit wrong. Why is the... Oh yeah, it's a radius. Excellent. So when we say pixel size at depth, so we scale the pixel size at the near clip plane all the way up to here at this depth. How big is a pixel there? It's like, I am this big, for instance. And then you're basically saying, add the radius to that, and then square it, right? And now do the test between the distance from this point on the ray to here, so we've got that distance. Is it less than the pixel size at depth plus the radius squared, right? And if it is, the ray missed by somewhere around a pixel or less. So now we can do the logic to do the anti-aliasing. Now, this was way overcomplicated because I need to do like a near miss thing because it wasn't sorted front to back. Now it's sorted front to back. This is all easy. We've got a near miss in world space, near miss in screen space. There's some divisions here that I can get optimized later. But now I've got the near missing screen space. So that should be why is that? It was disabled? Miss distance. Right, now that looked weird. Right, miss distance screen space. So you want it to be opaque closest, you need to inverse it. So you need to take the color of the thing you've just basically scrubbed against. Now obviously the color needs to get calculated in some other way. But you take that color and you then say, hey, color.alpha is equal to the one take of this. Bearing in mind you probably want to min this value with 1 just in case. Then just in case the estimate was a bit wrong, then you want to blend front to back. Yeah, then we blend that onto there. I think that's it. So none of this near miss stuff anymore. It just sort of just blends it in, which is great. So there's like a has hit or found hit or something like that. Found hit is kind of dumb now. Wait a minute. Yeah. So now it should just be color.a. That's greater than or equal to greater than 0. Then we want to put a pixel on the screen. This was in the near miss thing as well, and changing the color. Terrible idea. This is going to calculate sphere color. This was in like lighting and stuff. Yeah. So we actually want to move that into a different place now. Yeah, the sorting stuff is all done now. So it sorts it front to back and into the tiles, which is great. Still got to see performance though. We're going to check that in a minute. So yeah, I think you're going to be spending a couple of streams just fixing any things which are crucial bugs like crashes, and then improving the performance as well, just to see how good we can get this method of binning the spheres into screen tiles. Doing a bit in the office today, so I'm a bit tired. Yeah, I get you, man. Yeah, probably do the same thing too soon. So we got this calculates sphere color. It's basically just doing some fixed light, basic light thing. It's also just, well, it was doing that, but it's just rendering the normal. That's the color we're getting right now. But yeah, we can just toggle this. I haven't toggled it for a while, but yeah, we could just toggle that. So what I want to do is actually, where we do this coloring, so you do color here, we're just going to say calculate sphere color. So you put in the color there. Now you don't bother doing this closest normal stuff, right? Instead, where's the normal again? The normal should just be in color. Oh wait, sorry, hit dot normal. Right. And then that will just return to you a color. I think that's right. Yeah. So before we do when we did the near miss as well, we want to do that here. So you do the blend, you do the color calculation, and you blend it in. Yeah, so we've also got this closest hit depth. I don't see that being set anymore, which is kind of annoying. Or Where is all it? Oh, this is the BVH ray tracer, right? That's the old one. We're gonna do a new one soon. Closest hit depth. This is probably going to be here. So closest hit depth equal hit dot T, I think it is. T min maybe? I forget these naming things. T, okay. So we can get the hit position there and that'd be the depth. All right, so I think that's good enough. Right, I thought I got rid of this. No, I didn't. Then if we got color, we output it to the screen. But realistically, we could probably do something like this, where we say if closest depth. Well, all right. No, if you got color. Yeah. Okay, that's good. Enemy one, that's cool, man. How you been? How's your day going? Right, sphere is called S, apparently. Good name. What's going on here? Does not implicitly cast to a... Okay, whoops. So it apparently just does the unpacking for us. Yeah, you know, when we do better lighting or whatever, we'll improve that. Yeah, but make it better, but for now it's just fine. Closest near miss. We don't have closest near miss anymore. We want to just blend over since we're doing it in order. Color.a, final color. Sweet, that should be it. Right, so should we see some good anti-aliasing? Hopefully. Shouldn't see any of those black pixels anymore. Does pixel size of depth assume 90-degree field of view? It's just a rough estimate, basically. So I think my field of view is actually quite high at the moment because I'm testing out the extreme values of that. But yeah, currently it's just a rough estimate. Have you got any suggestions to improve that, if there is? Because it's easier to, it's less precise if I multiply it out, but and it's quicker. But yeah, it's just quicker. I'm so happy the tokenizer works. It's not generic. That is what it handles now is hard coded. It doesn't read the grammar file. Nice. I'm still so happy it's running again and again. Cool. No, I'm not. Not quite. Just tired. But yeah, that's cool. Yeah, I've never really used any programming language grammars or anything. I just hard coded the, like, programmed the, or handmade the parser, right? Right. Hopefully this works. Okay, so we're getting. So when it gets further away on that looks like a great effect. That looks funky. It's like little islands. Anyway, let's take another screenshot. Don't know why I'm dragging, but hey. Creator, here we go. Right, so we're clearly doing something near the edges. I wouldn't call it correct though. Right, that's why it was looking so weird. You know, we're definitely seeing some form of blending going on. I just don't know if something clearly wrong about it. Do we not set the hit normal properly? So it's trying to do lighting or something on it. Yeah, you don't hit, so your normal is going to be wrong. I think, right? So yeah, you don't have a normal. We only set it there. So there's the problemo. So we just want to unpack the color here. Maybe we can do a quick and dirty normal. Because you're probably going to want that. Because if not, it's just going to be lit. So what you probably want is a quick and dirty normal. There's no hit position though. But we can probably calculate one. So we can go out to the pixel ray to sphere. Yeah, so along the ray direction, I can get to the hit depth basically. I can get to the I can just scale. Yeah, I can get like a closest point, which will basically just be a multiply with scalar from ray direction It's in view space though. Do we have a ray origin? Basically non-existent. With depth. So that's your closest point. Then you can just do subtraction from the center of the radius and get the normal. But that won't work. Dividing by radius won't work. You'd have to do a normalize. So I was avoiding a square root basically. But yeah, that's all right. So I think we try that. It should improve the quality. Of course, sphere doesn't exist. Can we project the point on the sphere and point on the ray? And can see the distance of the projected points. They're now in screen space between 0 and 1. I coded up a super basic ray tracer that just tested this out last time. You did identity editing. You keep doing interesting stuff. Awesome. You can probably ignore everything except the change in main at the bottom. Thank you, Rosmosco. Well, you've been watching since then or something like that. I remember now. Sorry, this is Cranston. Sorry. Why did I call you Rosmosco? Where am I getting confused? You know what? You come up as. Oh no. Responsico came earlier. You guys got the same color name. Yes, Cranston, thank you. Right. Where? Yes, I remember now when you helped me this. Right. So, right. Yeah. Main at the bottom. Right, okay. See the distances. They're now in screen space between 0 and 1. Ah, you did it. And actually got an output file as well. Nice. Um, so, well, you can probably ignore everything except for the change in main. Okay. Right. Um, oh, that looks elegant. So you're getting a length. Good old GLSL. You're saying ray point. Right, so I guess that's just a multiply. Then you're misses a vector between 2 points I described previously. Right. Right, I see. It's the distance between the 2 points. So, okay, from the center position to the thing, right? Oh, then you're putting it into screen space and you're taking the. Right, you've put it into screen space. And you're doing the distance in there and it's more precise. Right. I see. So you're just taking the 2 points back into screen space. So I'm just avoiding. I'm only taking one space back. Yeah, one. Because I wanted to. But this is probably quite. I wanted to avoid the divisions, but thinking about it, I probably don't have to do divisions. Or at least that division here. This could be more hard coded. Yeah, why did you go and use CMake? Why did you use CMake, huh? Right, let's give this a go. See what we get now. So let's do another screen. Grab. Give this a go. Right, this is looking way better. Look at that anti-aliasing. Oh, look at them spheres. Isn't that looking nice? Right in the shade, look at that. Oh, nice. But we've seen problemos. Um, that's probably because that's the holes, right? That's probably to do with the that is the occlusion buffer. That's nothing to do with the anti-aliasing. That's cool. Um, yeah, they're just holes that come from the occlusion testing. You see in the background in it, basically. That's fine. Ugh. I don't know what this. No, it's fine. You're not weird for disliking. I dislike CMake too. Don't worry. A lot of us dislike it. Basically, Yeah, I'm not a fan of build systems in general. I believe that it's quite easy, especially if you're just in hobby stuff, just to make your own basic script file that just does it. No, no ray tracing hardware. It's all done in a compute shader. We need more pixels. More. More pixels. Well, right now we've got a weird resolution of like, it's basically an extended 720p resolution. It's like just extra Y pixels. But I want to change my pixels because I did a benchmark, you see. So we need to bench, and I want to see how faster and slow this is compared to the last one, because we do some sorting now, and we do proper anti-aliasing. So, whoa, no, it's so damn noisy. I can't see it. I don't know. I see it. That's distance like that, I think. All right, what we got? So it was 5 milliseconds in total, the old one, and it's 2 milliseconds on the ray tracing. So let's take a look at another frame just in case. So it seems like we just made things slower. Bing, and we did more work. So I was expecting this to be cheaper. Because you should be earlying out. But yeah, there's that. Right, here's a 5 millisecond one. Oh, so it is cheaper. Right, so I think that the frame that we just looked at was the OBS. Was the OBS coming in and saying, oh, baby. Oh boy. So yeah, I think it was OBS kicking in and stealing some of my frame time. So it's basically about the same. But we've added sorting in. So we get better rendering. Wait 2 seconds, let me just sort the boy out. I'll be right back, 2 seconds. Right, welcome back. More pixels. Yeah, we should really test out more pixels at some point. Any ideas how you isolate benches so you get less noise from other apps? Yeah, I don't know. It's difficult. It is difficult. Plus, I've got a ton of my own noise, different kind of noise. I've got a load of. I need to group all of these up a bit. I think we might benefit from. Maybe we should increase the number of pixels because we can just build this into the game rather than print it out in the damn terminal. I've got a UI library. Why don't we actually use it? Why don't I just literally make a way to just pop something up, 4 to 10 times to get a good idea. Right, so what you're saying is just take an average. Yeah, we could do that. We can accumulate we can just accumulate total value over, for every time the shaders ran or something like that. That could be a good idea. But the problem is when you have multiple executions of the same shader, like this gets ran like many times. It's not really good. Hmm. Yeah. It's difficult. Things definitely run in the same order, if you will. But yeah. I wonder if we can build this into, like, we can add ways of, if we build, if we can add ways to make this more like a tree where we can push and pop basically expandable items, right? We could, like, we spent, streams doing a UI library. You can see part of it at the top left. Damn it. I just made it freeze somehow. No. Please don't die. Alright. We're still here. It's good. So yeah, this is not it's not great when you fix that, but anyway. Back to things. So we do have this, which is really great. Yeah. Yeah, there's holes. It's really weird. No, holes are fine, I think. Yeah, because only the opaque bits are. Yeah, because that's the anti-aliased bits or something like that. Hmm. But yeah, anyway. But yeah, maybe we can build this into the game. Just have a way to press a button, and we can get some little UI that just pops up or something. Maybe in a little draggable window, but I don't know if it should be in a little window. Maybe it should be fixed to something, and it just has all, or it's just at the side. Yeah, stuff to think about. And then we have collapsible columns, oh, it's not columns, rows that can, and we can see total frame time for groups of things. So this whole sort thing takes many passes, and that just gets in the way of everything else. But some of these names are also quite bloody long, and that could be annoying. Um, but yeah. Um, yeah, so what I... Oh, for crying out loud, it's froze again. Right, so what I'm looking to do next is to probably fix the gaps in the rendering, increase performance as much as we can without doing anything too crazy, I think. Just improve the performance. We want to try and see how good we can make this, and then probably scale up the number of instances so we can test how, we put 100 instances or maybe more down. Can that work? Yeah, we need to fix the crashes as well, these bugs. And that's what I want to work towards, is just proving out this tile bidding strategy and seeing if we can add complexity to the scene. And yeah. And then we can figure out what we want to do from there. I think we want to try another method out. Yeah, it's a weird bug. Weird bug. It just crashes randomly. I think it's when the stuff goes off screen. We can test that out. Yeah, it's off screen right now. It's just back to front. It's something... We can disable the shaders one by one. Thankfully, it's not actually crashing the GPU. And destroying the whole thing. So if we go to this, if we disable the tiled ray tracer, and then I guess in turn we have to turn off the reprojection step, because we're not actually reprojecting. We're just copying the depth buffer. I'm just describing intent here with my variable names. Oh, okay, the stream froze. Right, audio was fine though. Yeah, I guess just GPU got stuck on a single shader. Right, so we take this off the screen. Okay. It's definitely in the ray tracer then, damn it. So when they go off the screen, it's probably when you get 0. Yeah, it's something to do with this tiled ray tracer when it gets all the entries. Like yeah, something to do the way where it gets to start and end index. And somehow it ends up being set to something when they go off the screen. Oh, we can do that debug drawing that we did. When we did that sort of like prepare spheres. It's very, we did this, which was really cool. So we could debug draw those tiles. Oh, there's too many of them. Whoops. If we go to the prepare clusters, we can say, hey, just render the first LOD that has spheres, and don't bother rendering any higher LODs. Right, here we go. So we take this guy off the screen. There you go. That's the problem. It just fills up the whole damn screen. Somehow, right? There's the problem we've got to fix. It happens backwards as well. This is behind the camera. And it's rendering stuff. That's really bad. So I think it probably comes from the clusters. Like the clusters are saying, like, the screen banding box is working back to front. So it's behind the camera. So, yeah. That's basically the crash that we've got to fix. And then we can improve the performance, get multiple instances, probably see what it's like to go up to... I'm not worried about making perfect rendering. I just want to make sure it doesn't crash. And we can get the number go down. Music playlist? Yeah, just Stone Rebel. That's what we play. Stone Rebel releases stuff all the time. It's amazing. So just search Stone Rebel. I'll drop this one in the chat anyway, just so you have a link. But if you just search for Stone Rebel, you'll find his channel. Or I think 666 Mr. Doom posts his stuff. This guy is Psychedelic Angel, so I don't know where it originates from, but yeah, there's stuff that comes out every month, and it's great. Yeah, by stuff I mean there's a whole album. Right, I need to jam because bed sounds good. But I'm gonna give this guy a raid. Rendering Unicode, excellent. I'll next be on Thursday, 7:30 p.m. GMT +1. We'll carry on with trying to get these Yeah, make this rendering good. Go fast. Right, have a good tomorrow, and I'll see you all Thursday or Sunday. Have a good one. Sweet.